In this video, we will try to understand the inner working of ArrayList. We know that ArrayList is basically backed by an array. Although arrays are fixed size data structures, but an ArrayList is a resizable array. That means the internal array will be resized as and when required automatically. We don't need to take care of the sizing. So let's start. When we create a new object of ArrayList, an internal array is created by the runtime. The size of that array is dependent on the size that we provide. So for example, in this case, if we call the ArrayList constructor, the default constructor, without providing a size, then in that case, it will create an empty array. This is the empty array. So if we see the code of default constructor, it is initializing this element data. This element data is nothing but the object array. That is the internal array that will hold the elements of ArrayList. So in the default constructor, this object array is being initialized with an empty array. So if we don't provide any size, and if we are using the default constructor, then it will simply initialize an empty array. There is nothing in this array and it cannot hold any elements. But if we use the second constructor that basically accepts this initial capacity, in that case, the internal array will be created of the same size, the size that we provided. So if we called this constructor and passed a value 12, for example, then a new array will be created with size 12. But if this initial capacity is 0, then again an empty array will be created. So if we passed the value 12, then a new array will be created with size 12. Otherwise, again an empty array will be created. Then if we are using third constructor which accepts a collection, in that case, what it does, it checks if this collection is empty or not. If the collection is empty, then the array will be empty. This else case basically. But if the collection is not empty and if the collection is another ArrayList, then what it does, it simply converts the ArrayList to an array, and that same array will be used as the internal array. Otherwise, a new array will be created, element data, and what it will do, it will copy all the elements from the target collection to this array. Ultimately, there will be an array created by the runtime whenever we are initializing a new ArrayList. All right. Now let's move on to another method. There is this method trim to size. What it does, for example, let's say we created an ArrayList and we passed the default size 10. So there will be an array with size 10, 0 index, 1 index, 2, and similarly the last index will be 9 and the size will be 10. So that is the size of the internal array, but the array may not be filled completely. I may have only 4 elements in this list, in this ArrayList. So for example, this is an ArrayList to hold integer values and I have only 4 values in the ArrayList, 4, 7, 1, and 2. That means the size of the ArrayList is basically 4 because there are 4 elements in the list, but overall memory or the capacity of the ArrayList is 10. That means there are 6 slots which are empty. Now if we want to trim the ArrayList, if we simply want to have the size same as 4 because there are 4 elements, in that case we can use trim to size method. What it does, it trims the capacity of the ArrayList and it makes the size same as the capacity. So that means all the additional slots will be deleted and the final ArrayList will have 4 capacity same as the size. So that is trim to size. All right. Now we created an ArrayList and the internal array has been created. The next operation would probably be to add elements to this ArrayList. So let's see the code of add method. So we see when we call the add method, when we pass a new element to be added to the ArrayList, the first thing it does, it modifies the mod count variable. So mod count variable is basically to track the modifications done on this array list. So if we are adding an item, that is a modification. If we are removing an item, that is a modification too. So it keeps tracks of all the modifications. In the add method, it will simply increase the mod count, and then it calls an internal method add. It passes the element data is internal array, and size is the current size of the array. In the add method, first thing that it does, it checks if the array list needs to be increased or needs to be resized. So it calls the grow method. If the internal array needs to be resized, the code calls the grow method to grow the array list. Grow internally calls another method, grow, and it simply passes the current size +1. It is an indication that we need to resize the array. Now, if we look at the code, this else basically handles the case when the array list has been initialized with an empty array. If the array list has been initialized with an empty array, in that case, a new array is created with the default capacity. So if we see the default capacity variable, it is 10. That means if the internal array is empty, in that case, when we call the grow method or when the code calls the grow method internally, it will create a new array of size 10. So otherwise it tries to increase the size by 1.5 times, and it basically ensures enough capacity so that it can hold all the elements. All right. After the resizing, what it does, it basically copies the element from the old array to the new array and basically assigns the new array as the internal array. So for example, let's say at time t1, we had this array with size k, and it has all these items I1, I2 to ik. This is at time t. Now we call the add method here, add I item. Now it checks that okay, there are no more slots, so it needs to resize the array. In that case, a new array will be created by calling the grow method. All right, let's say this size is m, where m is greater than k. And once the new array is created, we need to copy all these elements to the new array. That's what it is doing here. It is simply copying all the elements from the old array to the new array. So that is add method. Whenever we are adding a new element, if the internal array needs to be resized, it will be resized, and all the old elements will be copied from the old array. And the new and the bigger array will be the new internal array. So if you see, the array is being basically reassigned. Okay. So that is the add method. Size simply returns the size because it always maintains the current size. Is empty simply checks if the size is 0 or not. Contains. What contains does is internally calls the index of method, and index simply checks the index of the value that we passed. So if the value that we passed is null, then it starts the loop from the start to the end, and it checks if it finds a null value. If it finds a null value, that index will be returned as the final output or the final result of the index of operation, and the contains will return a true. Now if there are multiple null values, then it doesn't matter. It will always return the index of first null. Similarly, if the value that we passed to the contains method is not null, then what it will do, the code simply checks the Similarly, if the value that we pass to the contains method is not null, in that case, it will iterate the array and it will check each and every element. If it finds a match, then index of that element will be returned, and contains would return true. So if you see inside the loop, it is simply calling the equals method. So it is checking each and every element with the passed value. So that is index. Similarly, if we call the last index of, then it inverts the loop. Instead of starting the loop from start to end, we are starting from the end location and checking the same thing. If the past value is null, then we are testing for null. If it is not null, then we are basically checking the equals method to find a match. Okay. ToArray simply converts the array list to a new array, which is the object array. To do that, it uses the copy of method of arrays, creates a new copy of the internal array, and returns the new array. But if we are using another variant of ToArray that also accepts the type of the array, in that case, a new array or a copy of that internal array will be returned. The only difference is this time it will make sure that the return type of that array is T type of array that we passed instead of the object array. Okay. Get method is a basic array operation, so we pass an index and it calls this method element data, which simply retrieves the value from the internal array. If you see, this is the simple array operation, getting the value by index, and it returns the value. So that is get. Similarly, set. So for example, if we are calling the set method to set this element at this index, what it does, it will first get the old value from the array, then it will set the index with the new value, and it returns the old value. So the simple array operation. To iterate the array list, to iterate all the elements, we often use iterator. To get an iterator, we can call the iterator method that will return a new iterator over ArrayList. Now, so if you notice, this iterator is fail fast. What it means that when we get the iterator assumes that nobody else is changing the array list. While iterating the array, if it finds a mismatch, if it finds that the array list has been changed, then it fails by throwing the concurrent modification exception. So it does not assume things, but it fails quickly. That's why it is called fail fast. Now, how does it keep track of modifications and how does it throw the concurrent modification exception? So let's see. We know that ArrayList internally tracks the modifications by using mod count variable. So let's say we have an ArrayList and so let's say we have an ArrayList and this is the internal array, and mod count was initialized at 0. When we added one element here, 1, this mod count will be incremented and the new value would be 1. Similarly, when we added another element, let's say 4, the mod count will be changed to 2. Adding one more value and the mod count will be changed to 3. Now at this point of time, let's say we called the iterator method and we got the iterator. Now what it does at this point of time, when we call the iterator, it stores the current value of mod count in an internal variable. You see, this is the variable expected mod count. So when we get the iterator, when it initializes a new iterator, it stores the current mod count internally in the variable expected mod count. So at this point of time, when we got the new iterator, the iterator has a copy of mod count, which is basically 3. And while it is iterating the array, so if you see in the next, in the has next, in the remove, in all these methods, it is calling this check for modification method to check if someone else is changing the array or not. And in this method, it simply checks the mod count and expected mod count. If it finds that mod count and expected mod count, they are not equal, it means someone has changed the array list. In that case, it aborts the operation iteration and throws the concurrent modification exception. So in this case, let's say the mod count is 3 and the copy is also 3. So there will not be any concurrent modification exception. But while we were iterating over the array, let's say some code changed the array list and added one more value, 5. Now what happens, the mod count will be incremented and the new value of the mod count will be 4, but this copy remains 3, and that's how it checks that the array has been modified. In the next iteration, the mod count and expected mod count, they will not be an exact match, and that's how iterator will know that array has been changed, and it will throw the concurrent modification exception. So that is more or less on the array list. There are so many things in the official source code that you can go through, but it covers the basic things, the basic working of the array list.